During the period from a few hundred years BC until the 1600s, astronomical worship gave way to scientific observation. This change was ushered in largely by the Greek civilization. No longer content to look on in wonder, a conscious effort was made to explain the workings of what they saw. Information from the Babylonians, Egyptians, and Chinese all came together in the Greek definition of the universe. The Greeks were able to develop a scientific view of the universe due to several advantages that previous civilizations did not have. The Greeks had an excellent understanding of mathematics and geometry, which allowed for thinking in three-dimensional space. And equally important, they had democratic rule and a spirit of free thinking. This proved critical to scientific analysis, and is something we still depend on today. Thales lived from 636 BC to 546 BC. He was the first Greek to try to explain the world in physical terms rather than mythological terms. His image of the world consisted of an earth disk covered by a sky arch, all floating in an infinite ocean. Anaximander later refined Thales' model to give the earth disk a thickness of 1/3 its diameter, and he believed the sky consisted of rings containing holes that let the light in. These holes gave us the appearance of the sun, moon, and stars. Aristotle believed the Earth to be a sphere, the perfect object, and proved that it was at the center of the universe. His proof involved parallax observations to show that the Earth did not get closer to the stars over the course of the year, and therefore must be stationary. This is of course not the case, due to the extreme distances to the stars, which Aristotle and others could not possibly have recognized. His proof appeared to be valid. Heraclides, who was a disciple of Plato, developed a model in 310 BC to explain retrograde motion, with again the Earth at the center of rotation. Hipparchus applied Greek geometry to information that had been archived by the Babylonians in an attempt to explain the motion of the stars and planets. He discovered the precession of the equinoxes and predicted that it was approximately 1 degree per century. This is quite accurate, as we know today the precession accounts for 1 degree in about 72 years. Hipparchus probably thought that the stars were moving in precession, and not the Earth. Claudius Ptolemy lived from 100 to 170 AD. Expanding upon the ideas and information of those before him, he developed a working model for the solar system. This system could be used to predict the movements of the planets as well as sun and moon. The system involved many disks, or differents, with off-center points of rotation, with other disks moving along its circumference. These other disks, or epicycles, held the planets, which moved along the epicycle's circumference. This model lasted for 1400 years, and yet was completely inaccurate at modeling the actual workings of the solar system. It did, however, work as a method of prediction. Ptolemy also revised and refined earlier instruments to produce the astrolabe more familiar today. While the Greeks were trying to explain the motions of the stars and planets, the Chinese were studying the sky using a different philosophical approach. Their methods involved historical observation and record-keeping of all events. This information would later benefit astronomers by providing information about phenomena such as comets and sunspots. It is believed that the Chinese were studying sunspots through smoky crystals or jade as early as 28 BC. The Greeks seem to have ignored these items in their astronomical pursuits, since they could not be easily explained. On July 4, 1054, the Chinese observed what they termed a guest star appear in the sky. This star was brighter than any other at night, and may have even been visible during the day. It is believed that this was a supernova of a star which we now call the Crab Nebula, or M1. The view of the universe changed very little until the 14th century. Nicholas Copernicus went against the establishment and risked charges of heresy or witchcraft to produce a radical work proposing that the Earth orbits around the Sun. Since Copernicus was himself a cleric and a skilled promoter, he was able to avoid any dangerous repercussions of his work. Copernicus's theories were based largely on other people's observations, and he included only a few of his own measurements and calculations. The theory was based largely on intuition. It was also not a simple model. Almost as complex as Ptolemy's system, Copernicus made use of epicycles revolving not at the Sun, but at a point close to it. This was necessary to maintain circular orbits for the planets. Copernicus's theories were not largely regarded during his life, and he died just after his publication De Revolutionibus was released. The Dane, Tycho Brahe, could be called the first modern astronomer. He gained early fame and recognition for observing and recording a supernova in Cassiopeia in 1572. This event was to change his life. He made very extensive and accurate measurements of everything in the sky, and even calculated the length of the year to within 1 second of today's accepted figure. In 1577, he observed a comet and determined that it was quite distant and not within the Earth's atmosphere, as had been previously thought. Tycho Brahe never believed in the Copernican model, but instead thought Ptolemy's was the correct system. His last achievement was to launch the career of a young astronomer, Johann Kepler. Through the conceptual work of Copernicus and the analytical data of Brahe, the beliefs of the world were about to be radically and forever changed. Please select another time period for further historical information.